In monolithic applications, we might use ACID for our database transactions, which stands for atomicity, consistency, isolation, and durability to ensure data consistency. However, with microservices architectures, we don't have this luxury anymore. Instead, we need to come up with a different approach to ensure data consistency among all of our different services. For example, in our current system, when we create a new building, we first insert a new building into the database and then create a new workflow for this building by calling the workflows service. However, what if the workflows service is down and our message broker fails to deliver the message later? What if, for some non-obvious reason, the workflows service fails to create a new workflow for this building? Well, in this case, we'll end up with an inconsistent state in our system, and also, we won't have a mechanism in place to recover from this state. We could, of course, wrap both calls in a database transaction and roll back data changes if the workflow creation fails, but this isn't always that simple. If we had multiple services involved, let's say services that must be called in a specific order, some changes might be already committed to the database, and rolling back local changes wouldn't help us that much. It might even put us in an even worse situation if some of those rollbacks failed, etc. So, how can we solve this problem? Well, there are several different approaches out there, but in this course, we'll focus on two of them, the inbox pattern and the outbox pattern. There's also a third technique called sagas, which is useful for designing long-running business transactions. But unfortunately, we won't have time to cover that in this course, but we dive into it in the Architecture and Advanced Patterns course extension, as it's a much larger and broader topic. With these inbox and outbox patterns, we can achieve the so-called eventual consistency model, which means that the system state will eventually become consistent, but as the name implies, it might take some time. In other words, we can't guarantee that the system will immediately become consistent, and we need to take this into account. Whether we can use eventual consistency in our system or not depends on specific use cases, application requirements, and business needs. So always make sure to carefully evaluate the pros and cons of each approach before making a decision.